In this video, we'll be talking about three different topics. The first one is the phosphoric acid or the phosphate linkage or simply the phosphate. The second one is the nucleotide and the third one is the nucleoside. In the previous videos, we were seeing what were the different components of nucleic acid and we finished what is a sugar base, what are the different pentose sugars that is found in the nucleic acid. Followed by that, in the next video, we also saw what are the nitrogenous bases. In this video, we'll be seeing what is a phosphoric acid, that is the final portion of a nucleic acid, and these two terms, the nucleotides and nucleosides. What is the relationship between the two? How do they form nucleic acid? We'll see about everything in detail. The first one, let us start with phosphoric acid. The phosphoric acid is also called as the phosphate linkage, or sometimes they would simply term it as phosphate as well. And what is the structure of this phosphoric acid? If you look at phosphoric acid, it has got 1, 2, 3 OH groups. So what happens is, apart from this 3 OH group, there is one double bond O. This is the structure of a phosphoric acid. It has got 3 OH and one double bond O. Now what happens during bond formation is, one of the OH bonds, it can be anything. It can be this or this. Any one of the OH actually bonds with the fifth carbon of the pentose sugar. Now this can be either ribose, if it is going to be an RNA, or it can be deoxyribose, if it is going to be a DNA. So based upon whichever sugar molecule it is, one of the OH actually bonds with the fifth carbon of the pentose sugar. So this is the basic way in which the phosphate serves as a link, and using the phosphate, the bridge is formed as the DNA molecule. Fine. Now what is the nucleotide? What I'm going to do now is, we already saw in the previous section that this is a sugar molecule, a pentose sugar. The sugar that I've taken here is deoxyribose. And how do I identify that this is a deoxyribose? Very simple. I've got only one OH here. If I've got one OH here and one more OH here, it means it is an unstable compound. So basically a ribose sugar is an unstable compound, but here you find that it is very stable. So this is a deoxyribose. And we saw in the previous video also, the carbon is being bonded to a nitrogenous base. And we also saw there is always the first carbon that is getting bonded. And if this is going to be the first carbon, based upon which nitrogen is going to be bonded, it can be the first nitrogen, it can be the third nitrogen, it can be the fourth nitrogen, seventh nitrogen. Based upon which nitrogen is going to be paired, it can be a purine or it can be a pyrimidine. So basically, the carbon is getting bonded with the nitrogenous base. And what kind of bond is getting formed between them? That bond is called as a glycosidic bond. So you would have already read about it in biomolecules. So the carbon and the nitrogen is being got together. They are getting bonded together with the help of a bond that is called as a glycosidic bond. Okay. Now there is a pentose sugar and there is a nitrogenous base. Now what happens? This phosphate linkage comes. Now when I attach the phosphate linkage to this, what happens? We already saw that there are two OH and one of the OH actually gets bonded with the fifth carbon of the pentose. Now what is the fifth carbon? Now let us see the fifth carbon. Now when you look at the fifth carbon, 1, 2, 3, 4, 5. This is going to be the fifth carbon. And in fifth carbon, this OH bonds with the hydrogen that is present at the loose end of the fifth carbon. It is HOCH2. The technical structural details as we progress in the lesson we'll be seeing. HOCH2. The free end hydrogen actually bonds with this OH and they combine, and when I put OH and H together, it is nothing but H2O. So the water molecules completely get eliminated, or in simple terms I can tell, the water moiety gets reduced to 0. Excuse me. So the water molecule gets completely reduced to 0. When it is completely reduced to 0, this H2O will get eliminated. If H2O is getting eliminated, this OCH2 will be bonded with the phosphate and that kind of a bond that is formed between this phosphoric acid and the sugar molecule is called as a phosphodiester bond. I repeat once again, the fifth carbon, it has got a loose end hydrogen. This bonds along with the OH that is present on the phosphoric acid. As a result, water moiety is getting reduced, water molecule is getting eliminated. So since it is getting dehydrated, that is, water is being removed, it forms a bond between the phosphoric acid and the deoxyribose sugar or a pentose sugar, and that is called as a phosphodiester bond. Now, this is how a nucleotide is formed. So if you take a nucleotide as a whole, what is there in a nucleotide? It has got a phosphoric acid. Apart from that, it has got a sugar and it has got a nitrogenous base. Now let us write it. See, it has got a phosphate plus a sugar plus a nitrogenous base. This is what is basically present in a nucleotide. Then what is a nucleoside? We'll come to that. If you take a nucleoside, if you just remove this phosphate, what else is present? The sugar is present, the nitrogenous base is present. If you remove the phosphoric acid, if only a pentose sugar and the nitrogenous base alone is there, then you call it as a nucleoside. So a nucleoside basically consists of only a pentose sugar and a nitrogenous base. Now let us take an example. See, there is deoxyribose, which is found in DNA. That is a pentose sugar. Along with that, I have to add a nitrogenous base. Say, for example, I am taking adenine. So it is deoxyribose plus adenine, and we have to name it as deoxyadenosine. This is as per the nomenclature. I'll be teaching you that a little later. It is called as deoxyadenosine. Now, this deoxyadenosine is a nucleoside. Deoxyadenosine is a nucleoside. Now what happens? I take the same complex, deoxyribose and adenine, and what I do, I just add one phosphate linkage to it. When I add one phosphate linkage to it, it becomes deoxyadenosine monophosphate. So I'm just adding one phosphate to it, so it becomes deoxyadenosine monophosphate. Now this complex is a nucleotide. It's not a nucleoside. Now this is a nucleotide. Why is a nucleotide? Because a phosphate is attached to it. So I hope it's clear. We'll have a quick recapitulation of this. A phosphoric acid is also called as a phosphate linkage. It has got 3 OH to it, and one of the OH bonds with the 5th carbon of the pentose sugar. If you take a nucleotide, nucleotide basically consists of a phosphate, a sugar, and a nitrogenous base. And this sugar molecule is being connected on both the ends. So it is being connected on the first carbon to a nitrogenous base with the help of a glycosidic bond, and it is connected on the 5th carbon to a phosphate linkage, and that is with the help of a phosphodiester bond. And a nucleoside means it is same as the nucleotide, only difference is it does not have a phosphate linkage. If I add a phosphate linkage to a nucleoside, it becomes a nucleotide. So a series of nucleosides connected with phosphate in the middle is actually a nucleotide, and the series of nucleotides together is what is called as a nucleic acid.